Hi, I'm Tom Stephenson, and welcome to our course on cost control and construction. Today we're going to be introducing you to Earned Value Analysis, or better known as EVA. We're going to be looking at some aspects of why Earned Value Analysis is beneficial for a project. Some of the things that you need to be careful of. If you're not doing it, you probably shouldn't be doing Earned Value Analysis because it is a fairly advanced method of controlling costs and time on a project schedule that requires really good data and tracking and good fundamentals that we've been talking about earlier in this course. We'll also talk about how earned value analysis is calculated, some of the formulas. We'll go through some of them. We'll have an introduction to a case example, which we'll do a follow-up video where we'll really sort of grind it out on that particular case. But for this video, I just want to get a quick introduction that you understand the fundamentals, and really these formulas that you're seeing here are the same formulas that are used on the PMP exam. So if you're studying for that, or you plan to at some point after you've taken the course, then it's not a bad primer that way. So EVA metrics or earned value analysis, some of the basic points that you need to think about are three areas. Are our planned value. What have we planned for this course? What's our budget at completion? So if we're looking down the y-axis over here, we've got cost, and on the x-axis we've got duration, and so where they intersect over here, this would be our time and cost evaluation for the project, what we've budgeted for it. And this would be what we've termed in previous class sessions or video sessions is our baselines, our cost baseline and our time baselines. We also have our actual costs, and these are the actual costs that we would have incurred in the project up to this point, our status date. Remember, the status date's the date you're updating to. So that means it would have had to happen. Everything to the left of this line here, it would have happened. So we would have our actual costs that have been incurred up to this point. We could compare those actual costs to the planned value of the cost, but of course we also have to think about what did we plan to have done. So if we look at that a little bit closer, when we think about that, we've got several things to consider. There's the actual cost that we've incurred and how much is that above the budget amount. We also have where were we supposed to be on the project. Maybe where we actually are, we were supposed to be back here. So we haven't done as much, but we haven't spent as much either. We have to look at from that perspective. Or conversely, maybe we have spent a lot more to get us to where we are. So not only are we behind schedule, but we're actually over cost in that case. And if we know those parameters, and we know in percentage terms what we have incurred, then there's calculations that can be done to say, well, you know what? If we continued along at this trend, by the end of the project, we will be 3 months late and $2 million over budget. You know, you can do those kind of forecasts with earned value analysis. So you can see trends that are occurring, and trends doesn't mean it has to happen, doesn't mean it's going to happen. Trend will continue using Stein's law, as we've talked about earlier in the course, until it stops. Well, the goal is to see trends forming early so that you can take actions to remediate and mitigate those issues that are occurring. It may be on a very large project. You may also change some of the things in the design process that are further along that may not have to have, but would be want to haves at this point. And that could help to keep you within budget if there's no other means of getting back under control, but you want to meet the budget requirements. So there's a lot of things and uses for earned value analysis. So I have this sort of simple example, and just to point out, this should actually say 10 days here instead of 100 days. This is projects, it's got a work breakdown structure, things we've talked about in previous classes. Pre-construction, demolition, building systems, interior finishes, exterior finishes, closeout. It should total up to 100 days. Like I said, there's a typo there. And it is going to cost $10 million. And I've just taken sort of a straight line cost to this project the way it's been loaded, just thinking about it like it was evenly loaded during that time period. That, of course, is very, very unlikely, but I think it'll help you to visualize what's going on with how the formulas and how earned value analysis works. So you may see a bunch of acronyms, and some of them look similar. This is the old way of sort of assigning acronyms. This is the more adopted way now, actual cost. So this is the preferred way. Actual cost, also known as actual cost of work performed, this describes it better, to be honest, is the total expense that has been incurred from completing activities or portions of activities up to the status date. So that, of course, is this one here, our actual cost line, planned value, earned value. So those are those three areas. For the Smith County College renovation, this one here, we have the activities when updated to the status date of day 50 have incurred an expense of $6 million. So this project was supposed to take 100 days long and cost $10 million. At day 50, it's actually cost $6 million. Therefore, the actual cost of work performed during the first 50 days is $6 million. And we would have taken that from our updates, and then we would have taken that from what money that we've spent up to that status date. Earned value, EV, also known as budgeted cost of work performed, is the value of the budgeted cost of work performed up to the status date. So in the Smith County College, at the status date, we performed 40% of the actual work. Now, we were supposed to perform 50% according to the original plan. Like I said, it was evenly loaded across, but we're only at 40% performed. So very much like that chart I showed you just a few slides back. This is, we're actually over here, like 40%. 40% of the work is performed. So really, we had planned way back here to have that done, but we're over here, and we've only got 40%. We're not at 50% of the work performed. So if we take that through and we look at earned value analysis and where that's coming from, so like we said, we had a planned value of 50 days and $5 million to be spent, and we're at $4 million at 50 days. And then we got that number because we said that the activity is only 40% complete, right up to that point. So we're at $4 million because 40% of 10 million is 4 million. So the actual cost of 6 million indicates the project is also over budget at this point. So we're over budget and behind schedule, or we're underperforming at the schedule. Probably, if you want to get into technical earned value analysis, they'll say the performance, schedule performance is underperforming. You could be underperforming in some of the activities that have float. So it doesn't necessarily mean it's exactly behind by the critical path date. You'd actually have to review that. And we've talked about that in the previous classes, the update process, seeing exactly how many days you're behind. But it by and large gives you a really good indication of that you're behind schedule, more than absolutely likely in this case. But if you get into the technical terminology and you do want to do analysis when you're reviewing schedules, you'll find there's a lot of what I would like to call space between the spaces with some of these formulas, because there's a lot of things that can be derived by looking at the data much more deeply and thinking about what's going on specifically on your project than first meets the eye. So very often just saying things outright, got to be a little bit careful on that. So these formulas, and these are not all of them, but these are the major ones: budget at completion, schedule at completion. So these are your baselines. Cost variance, schedule variance, CV, SV. So cost variance equals earned value minus actual cost. Schedule variance equals earned value minus planned value. And then these are the occurrences that what the formula kind of tells you as a result. So if you have 0, then that means you're on budget or you're on schedule, because your EV minus your PV is basically equaling out to zero. So that means your earned value minus your planned value, they're on track with each other, right? Your earned value minus your actual cost, they're on track with each other. And earned value, you can really think about is this is the value that you're earning with each dollar, how well you are actually doing. So it's giving you a pretty good indication how well you are doing in dollar terms from that perspective. But really, a really good indicator is when you put it in those numbers and you utilize them and you put them into a cost performance index and a schedule performance index. I like these two numbers because it really gives you a good sense of what's going on. So you can think of the cost performance index equals earned value divided by your actual costs. So we take our CPI. If, for example, our cost performance index is less than 1, our project is over budget. So if we're at 0.5, or no, let's be a little bit more realistic. Well, you could be that bad, but let's say we're at 0.8. So our earned value divided by our actual costs, we're at 0.8. Well, 0.8 would mean that for every dollar you're spending, you're getting 80 cents, right? That's not going to be too great from that perspective. Every dollar you're spending, you're getting 80 cents worth out of it. Schedule performance index is giving you the same sense. Then if you want to look at it, if the project is 1, right, then you are on schedule. If it's at 0.8, then you are running behind schedule, because you would take, say your project's 100 days long, you would take that 100 days and you would divide it by 0.8, and it would give you something like, I don't know, I'd have to work it out, but I think it's around 125 days. Well, I'm talking about it. Let's work it out. So if we're 100 days and we're at 0.8, so we take our 100, divide by 0.8, and we get 125 days, right? So we get 125 days if we do that. That's giving us an idea. If this trend continued, this is how this would work out. Not too good overall. But again, there's some nuances in there, because all of that number might not be in on the critical path items. It may be some of it on the float items. So you'd have to review that and analyze that a little bit. But it definitely gives you an indication things are not going well from that perspective. From a time perspective, and this would give you definitely an indication that things are not going well from a cost perspective. If you were to take that, if you were running at 0.8, then basically you're less than 1, then you're over budget. So you could take your 100 and so if you were like 20,000 or 2 million over budget, you could divide that by 0.8, and that would give you 2.5 million. So if that was the case, it would be telling you if this trend continues, this is where you're going to be at the end of the project. Very helpful. Kind of scares you a little bit. If you're just doing a regular update, as we've looked at in previous lectures and videos, then if we just do the regular update, we see, okay, we're 5 days behind and we're 10,000 over budget. But if you carry that trend to the end of the project, it might work out to using this kind of information. Well, you're not 5 days. If you go to the end of the project, you'll be 15 days, and you're not $10,000 over budget. If you go to the end of the project, you might be 30,000. So it's really showing you trends very early on in the process. We also can do the estimate at completion and final costs if no action is taken after the status date. So this is very basic in this estimate at completion. You just take your budget at completion and you divide it by the CPI. So that's what I was saying. That would give you your estimate at at completion, right? That's assuming that your budget at completion is the same. Maybe it's more. Maybe it's going to be more based on what's happening. Maybe it's going to, there's going to be a difference, right? So you have to look at that. So if no action, this is final project cost if no action is taken after the status date. Estimate to complete. So you take the estimate at completion and you minus the actual cost, and that'll give you the estimate to complete. This is the one you can actually, you can revise and you can look at it, because maybe the estimate to complete, maybe you've got some more accurate information that's now telling you that your original estimate was quite off. You may want to, revise that, estimate at completion minus the actual cost. So there might be some revisions that would even change that. So this has a number of different ways that this can actually be calculated, but I am keeping this in very simple terms for this introduction. Estimate to complete equals the estimate at completion minus the actual cost. So this is using the very sort of straightforward, simple form. You can dive into this a lot deeper depending on the circumstances and what actions that you want to take. So this is where you can go really deep into earned value analysis, and it can really return some value to you. Variance at completion, well, budget at completion minus estimate at completion, that will give you the variance. It makes sense. Time estimate at completion, so this is taking your schedule at completion, dividing it by the SPI that I mentioned earlier, and that would give you that time estimate at completion. That's the one that I did where I divided 100 by the 0.8 and I came up with 125, which was saying that would in that case be 125 days. So time estimate at completion. Now if I know that that's at 125 days, I can say, all right, well, the schedule at completion, this one was 100 days minus the time estimate at completion, 125. So 100 minus 125, that gives me negative 25. So if that's the case, we're going to be 25 days behind schedule. So if we're less than 0, we're going to be behind schedule. So that's why minus 25 would put us that far behind schedule. Again, you'd have to be careful about that and review it regarding the potential for the adjustments in there with float and critical path. Kind of like you're starting, the start of the project, you're doing various updates and you're sort of seeing certain trends come around as you're proceeding, like at day 25, day 50, day 75, and you've got these different cost price index, schedule price indexes, right? So you can sort of see how it's changing as we go around and how some of the variables, and those would be somewhat dependent on the actions that you're taking on the project. And so if you're in this area, you're ahead of schedule and under budget, ahead of schedule and over budget, behind schedule and over budget. You kind of were able to, in this case, from this point of view, bring it back from a schedule perspective because you got it up to 1, but from a cost perspective, you weren't able to get it back to the budget. So you're a little bit under, but quite a lot better than where it was at certain points. If you just don't manage those processes that well, then you could be, really getting into negative territory, and that's where you get projects that are way behind schedule and way over budget. So the estimate at completion, EAC, is a forecast of the total project cost at the end of the project. The EAC is what the project will end up costing if no corrective action is taken after the status date. So just giving you that information. And that is that aspect of the budget actual cost divided by the CPI. So you can sort of see how this flows out. And I think we had that over there, right? So this is this formula there. And the estimate to complete, just reinforcing what I kind of just walked us through, is a budget forecast at which the total cost of completion from the status date to the end of the project is estimated. So we're really looking at the total cost of the project from the status date to the end of the project. So if we know what the project was supposed to cost, we know what we spent, then the estimate to complete is what's left. You kind of think about it in those terms. We know what the whole project was supposed to cost, our estimate at completion, which was developed over here. assuming that nothing changed. And then we're minus our actual costs. Well, the only thing that's then left is the estimate to complete. But this can be giving you some detailed information that can be quite useful. Variance at completion is the difference between the budget at completion and the estimate at completion. And as I said, time estimate at completion, that's really sort of giving you those raw numbers that you can calculate to see difference in time and how that's impacting the project as a whole. And if you see that that's ending up to be a large number, you got to really start thinking about what do I need to do to keep this project on track. So those formulas that are in that chart, as I said, pretty simple. You do have to spend some time to get your head around them. If you decide to do the project management professional exam, you really have to memorize all the formulas. You have to memorize them, write them down day after day just to get them in your head so that you can effectively answer the questions, because those kind of exams are closed note, closed book. So you have to know all of the formulas and how they're applied so that you can answer those questions. So in the next series of videos, we're going to look at how they're applied and utilized that way. As I also mentioned, there are some cautionary notes about earned value analysis. If you're going to use it on a project with this introduction, you have to be like spot on with your other practices in cost and schedule development. You know, you can't be starting to run projects with earned value analysis if you're having trouble developing a baseline schedule, if you're having trouble cost loading a schedule and doing cash flow statements and an effective work breakdown structure and assigning budget codes to the work breakdown structure. If you can't do that, then you're not going to be successful. And also making sure all the best practices in scheduling are covered. Things like making sure that you don't have any open ends on the activities, that everything is properly connected, that you have a proper and an effective critical path, that there's not these base errors in the original baseline schedule and baseline cost loading. You have a full integration with your project managers, your site team, your estimating team, your scheduler, that there's good collaboration and understanding and checks and balances in place. It really requires a systems approach to be successful at implementing earned value analysis. It's why a lot of contractors don't implement it, because to be quite honest, they have trouble with some of the basic fundamentals. So they don't really apply it unless they're told, thou shalt apply this, by a client who maybe they're doing a very large infrastructure project, something of that nature. In the industries of infrastructure, civil projects, industrial projects, EVA is the norm. That's what you find. In residential projects, it's not the norm. You don't see it that often. But if you're in infrastructure, if you're in civil projects, if you're in industrial, this is what you're going to see. This is how it's done. So I hope this has given you a little bit of idea of how earned value analysis works, and we'll be following up with this with more details and examples on how it actually is applied and how it works. I'm going to go through that college case in much more detail in the next video so that you have a better understanding of how these numbers are calculated individual right through the whole thing. So I'm Tom Stephenson, wishing you a wonderful day and happy cost control and scheduling. Bye for now.